Hi, and welcome to this section of the Physics 2 Tutor. And in this section, we're going to continue our discussion of thermodynamics, and we're going to tackle the second law of thermodynamics, which is a lot when you're in a practical engineering environment, when you're trying to design an engine or some sort of device that performs work. Because what you're going to find, and what we're going to learn in this section, is that there's some fundamental limits to how good of an engine you can actually build, how efficient of an engine you can actually build, and that's what we're going to poke on here. So I want you to keep in the back of your mind during the whole discussion in this section the concept of an engine, because really the second law is dealing with engines. And what I mean by that is exactly what you might expect. I'm talking about, like we were talking about before, a piston inside of a cylinder, and that thing can go up and down. Really, I'm using an analogy to a steam engine is really what I want you to keep in your head. But it also applies to combustion engines and all kinds of other engines that you could build that would perform work. Given some sort of thermal energy into the system and out of the system, and it would do work. So we're going to be talking about engines. So think about the piston and going up and down and doing that work, turning a crankshaft or something like that. It'll really help the discussion. So we're going to define what a cyclic heat engine is here and sort of draw some pictures, and we'll just go from there. Let's go ahead and start with a picture, because a picture is always the easiest way to get this stuff in your head here. Basically, what you're going to have in the most simplistic form of a heat engine is you're going to have what we're going to call a hot reservoir up here. So I'm going to write in purple, I'm going to write heat source. Okay, and this heat source is going to be at temperature T sub H because it's hot. T sub H is the hot source. So when you think about it, every engine that you can think of, whether it's a steam engine or a nuclear power plant or anything like that, you're always going to have a hot source, some sort of thermal, thermal energy, whether it's geothermal, you're pulling energy out of the earth, whether it's a steam engine, you're burning coal or something to boil water. A nuclear power plant, the heat would come from the radioactive decay of the isotopes that you have, whatever. You're going to always have some heat source here, and it's always going to be at some temperature TH that's very hot compared to room temperature. And what's going to happen is you're going to have this heat source, and this heat source is going to deliver some heat, obviously, Q sub H, to your engine, really. Okay? And what's going to happen as a result of that, I'm going to end up having to draw the whole diagram before you fully get it all, so I'll just try to get it out on the board. This engine is going to produce work. So that's why the arrow is going out of the system here. The system, the actual engine here, is doing work. So work is going out of the system. It's sucking in heat from some hot source, and it's doing something. What that something is whatever you design as an engineer, and that something does work. That's what we want engines to do, right? And because things aren't perfect, and you'll see a little bit more why here in a second, but all engines are going to deliver heat, Q sub C, to what we're going to call a cold reservoir here. So what you're going to find as we talk about this, every engine is going to have a heat source, and it's going to have, we're going to call it a cold reservoir. Okay, and we're going to say that this cold reservoir is at a temperature T sub C because it's T cold. So I'm going to draw some generalizations here, and they're going to be really important. Every engine has a heat source, a high temperature, whatever it is, nuclear material, steam generated because of burning coal, whatever it is. And every engine is going to have a cold reservoir. This is going to be, like in your nuclear power plant, this would be where the waste and everything, the wastewater goes into the river. You always have a river near a power plant because you have to have the cooling water to cool the thing off. That's going to be your cold reservoir. In an engine, like a car engine or a steam engine, the cold reservoir would be the outside of the engine. It would be the rest of the world. The hot stuff's inside the engine, the cold stuff's everything else. And we'll see in a refrigerator, which we're going to talk about in the next section, hot and cold would be inside of the fridge and outside of the fridge. So you can sort of see it's not rocket science here, but every engine's going to have something hot and something cold. Otherwise, you're not going to get any work done. So this differential here, the difference between these guys is basically going to end up producing this work. Okay, so let's write some things down, some generalizations down for heat engines. This whole thing's on heat engines. So I'm going to say the cyclic heat cycle. Okay, because everything has to be cyclic in an engine. You have to go around and around and end up back to some starting point, and then you can continue the cycle. So we're going to just write down what we've already said. What you're doing in essence is you absorb heat